So last class we discussed the Black-Scholes option formula. It's a very nice model which could be used to value European options, both put options and call options, both without dividend or without dividend. And this Black-Scholes model could also be used to value American calls without options. So we also talk about a major application of the Black-Scholes model. That is, we discussed about hedging. So what is the basis about hedging? Well, the basis on the hedging is to first calculate the hedge ratio or delta. And you can see that for this formula, for this Black-Scholes formula, this ND1 gives you delta. So you can see that it's a very quick way for you to figure out what is the delta. And after getting delta, you could build your hedging portfolio. Obviously, you can see that calculating this ND1 is not super easy because this D1 is somewhat complicated. Right? So you have to know the share price, the exercise price, interest rate, and the volatility of the stock, and the time to maturity, right? So obviously you have to understand how to plug in numbers to get D1, and then how to get this ND1. A very related formula is the Black-Scholes model for put options. So we derived this model for put option using put call parity. And you can see that without dividend, this is the model for value input. So you can see that the delta or the formula for delta in a put option is given by ND1 minus 1. Right? So this part. Okay. So that's for this mini review, and let's continue to discuss the hedging example. So let me figure out first where I stopped. Okay, so we have not discussed this example yet. So this hedging ratios example. So let's look at this example. Let's say you have two portfolios. So you have two portfolios. And for portfolio 1, you have 950 calls and 200 shares of stock. And for portfolio 2, you just simply hold 800 shares. And we assume the hedge ratio here is 0.6. So delta or hedge ratio, they're 0.6. The question is, which portfolio has larger dollar exposure to the FinCorp price movement? Right? Let's assume the stock price increases by $1. And let's see how many dollars our portfolio's value will change. Right? So let's look at this the simple case. The second portfolio. If you have 800 shares, and if for each share the price increases by 1, then pretty obvious, right? So the total value of the portfolio will increase by $800. Now what about the first portfolio? Well, the first portfolio has two kinds of assets. The first is call, and the second is the share. So for 9,500 calls, if stock price increases by $1, now you can see that because the delta here is 0.6, remember that delta equals change in call value divided by change in stock price, right? So if delta is 0.6, it means that if stock price increases by 1, then call price will increase by 60 cents. Essentially, this implies that the 9500 cost value will increase by 950 times 0.6. And of course, for 200 shares, their value will increase by $200. So this gives us, so let me see what's this gives us I believe it's 450. So you can see that the dollar exposure is larger in the second portfolio, right? Because it's 800 versus 650. Okay. Okay. Finally, let's look at the next application. So okay. So let's look at this the second application of the Black-Scholes formula. That is hedging on mispriced options. So what's the basic idea here? The basic idea is, let's say you're a option investor and you're in the market looking for mispriced options. So let's say you find out a option is undervalued, right? This basically means you should take a long position in this option. But option is a complicated derivative. When you're taking a long position in this option, you have to think, well, there are many factors could affect the option price, right? So even if I am correct in a certain prediction, then maybe some other factors will make me suffer from some loss, right? So basically, you will hedge against these unwanted risks. That's pretty vague. So now let's look at this very simple example here. So let's say, again, you're looking at this firm, which is called FinCorp. So let's say you're looking at its put option, and you think its implied volatility is too low, right? Again, we know that by Black-Scholes formula, the call options value and put options value, they both increase in implied volatility. So if implied volatility is unreasonably too low, then it means the put option is underpriced. So basically now you would want to buy it. Now what is your investment thesis here? You're basically saying that, okay, I think now the implied volatility is too low. So after holding this long position, I expect the implied volatility will increase, right? So I will benefit from the increase in this implied volatility. But as I said, you can see that a lot of factors could affect your put option price. For example, a very important factor to affect your put option price is the share price, right? And we know that put options value will be higher if stock price decreases. And the put options value will be lower if stock price increases. So this basically means that you're right about the volatility, right? You could still suffer from the potential price movement. That is, maybe in the end, you're right about the volatility. So the volatility indeed increases. However, at the same time, stock price also increases. So in the end, you will actually suffer from a loss because the increase in stock price will reduce your put option value, right? So what's your solution? Well, you will want to hedge your exposure to the share price movement. So basically, you can think about this process as this simple diagram. So you're looking at this put option value, right? You're taking a long position, so you want this put option to increase in its price. But let's say there are two factors which could affect your put options value. The first is volatility. The second is stock price. And as an investor, you're only betting on this. You're betting volatility will increase. So this is your investment thesis. You're not betting on stock price. So you will want to remove this part. So you will want to remove the effect of stock price on your put options value. Right? So you will want to result the effect of price movement. So how could you do this? Well, you might have guessed it. You want to hedge against this stock price movement by buying some shares, right? Obviously, the question is, how many shares should you purchase, right? Well, we have learned about this. When you're building a hedging portfolio, the first step is to find out this hedge ratio, this delta. So what is delta? Again, it's the change in the value of your put option divided by change in the value of your share. And through this delta, we could understand how many shares we have to buy to offset our exposure to FinCorp, right? I mean, this idea is pretty simple because basically we know that if stock price increases, then the put option price will decrease. So to solve this problem, I'm gonna take a long position in the FinCorp shares. So if share price increases, then I will get some gain from my equity position. And then this equity position will help offset my loss in my option position. Right? So that's the thinking of hedging. Okay, now let's make this more concrete. So let's write down some numbers here. So let's say the current implied volatility from this put option is 33%. And you estimate the correct volatility should be 35%. And you expect in the near future, the implied volatility will catch up. It will increase to the true volatility level, 35%. And let's say the time to expiration is 60 days. And we assume the share price is $90. And then we will buy a put option with the exercise price of $90. So this is the at the money option. And we assume the risk-free rate is 4%. So you can see that by Black-Scholes formula, using this number, risk-free rate and exercise at stock price, you will be able to find out the options price, that is 4.495. Oh, I think I forgot to mention, to use Black-Scholes to solve or to find out option price, you need 5 inputs. Right? So let me repeat this. You need 5 inputs. That is, you need implied volatility, and you need time to maturity, and you need risk-free rate, and you need exercise price and stock price. So you can see that we exactly have 5 inputs here. So this will give us a put price of 4.495. As an exercise, you can actually verify this using Black-Scholes formula. I know it's a long process, but you could practice how to use that formula, right? And delta, we could also find out delta. Remember that this is a put option, so it's delta equals ND1 minus 1, right? Again, we have a specific long formula for D1, so you could plug in numbers to get D1 and verify the delta is indeed minus 0.453. Now, what does this delta mean? It basically means that if stock price increases by $1, then put option price will decrease by about 45 cents, right? So this basically means that if you want to hedge against this stock price movement, then for one put, how many shares should you buy? Well, you should buy 0.453 shares, right? Now, we don't want this 0.453 shares. So let's say we want to think about 1,000 puts. Now, if you have 1,000 puts, then by the same reasoning, you will want to buy 453 shares. And you can verify that using this portfolio, you're hedged against price movement, right? Because you can see that if share price, let's say if share price increases by 1, right? Then your equity position will increase by $453. And what about your put position? Well, we know your delta is minus 453. So this implies that for each put, the value will decrease by 0.453. And you have 1,000 puts. So the value will decrease by 453. And you can see that these two numbers will offset with each other. So your portfolio's total value would stay the same. Okay, now let's crunch some numbers and see and verify that you will indeed get a positive profit and you're indeed hedged against the risk of stock price movement. So remember we have calculated the put options price, which is 4.495. Right, so this is put options price. And we also wanted to buy 453 shares at $30 per share to hedge against the adverse price movement. So these two numbers are our total expense. So in the beginning, we will have to shed out $45,265. Now let's look at the three different scenarios. So let's look at stock price movement, right? Let's say if stock price is $89 and we can find out put price. Of course, here the put price is calculated by assuming a implied volatility of 35%. Sorry. So why do you want to use 35%? Well, because in the beginning, the implied volatility was 33%. And you think it was too low. And you would assume that in the near future, the implied volatility will play catch up. And it will increase to 35%. So when you're trying to calculate what is your future payoff, your future profit, you will want to use this correct implied volatility of 35%. So now, given this implied volatility, obviously you can find put price, right? So you can see that we will have three different put price if we have different share prices. And then we can find out the profit on each put, right? How do you find out profit? Well, this was your price when you bought the put. And you would use this 5.254 minus the initial price. So the profit would be 0.759. You could do the same for the other two cases, right? So you find out the put price. And you can see that in the third case, we're having a negative number here. The reason is obvious because stock price has increased from 90 to 91 and you're having the put position. So your put options value will decrease. However, you can see that this variation in the put price because of stock price movement will be offset by your position on the FinCorp shares. right? So you can see that if stock price is 89, you can see that the value of 1,000 put options would be like this, and then the value of shares would be just 89 times 453. So the total position value would be 45571. And then you could do the same thing. So you can see that roughly speaking, no matter what is the stock price in the end, your total value would roughly be the same. And then you would use this total value, compare your initial total cash outlay, you can find out your profit, right? So you can see that roughly speaking, no matter what happens, you will get a profit of about $300, right? Again, you can see this offsetting effect. For example, if you look at this, so as stock price increases, your put option position suffers from a loss. But you can see that you're actually getting some gains from your shares, from your equity position, right? Because in the beginning, your purchase in shares, the total cost was 40770. Now stock price increases, so now you will have some gain here. So you can actually find out what is the amount of gain. Okay, let me pull out my calculator. Oops. So we have 41223 minus 40770. So the equity position, you have $453, right? So this is a gain. This is a positive number. What about your put position? Well, you have 1,000 put. So you can see that the loss here is minus 148, right? So you can see that at least the increase in the equity position value can completely offset your loss in the put option position, right? Now you might wonder, oh, this is weird, because you can see that there is some differences here, right? What you can see here is you're not exactly getting the same number. The profit actually changes, because theoretically, if you're having a perfectly hedged position, then the total value of your portfolio should stay absolutely the same no matter what happens. However, you can see some sort of variation here, right? What you're seeing here is some sort of convexity. That is, if stock price keeps the same, if stock price keeps at $90, my profit would be $290. And if stock price increases to 91, my profit is $305. And if it decreases to 89, my profit is $306. So, I mean, theoretically, you should get a flat curve. That is, theoretically, if you're actually perfectly hedging your risk, then it should be flat. However, you can see it's not. That is, as stock price changes, your profit will actually increase, no matter whether the price decreases or increases. This is a convexity, right? Remember we discussed about convexity. That is, if a curve looks like this, then it's convex. So the reason is because as stock price changes, delta also changes. Hedge ratio also changes. So if you want to perfectly hedge, you have to do some rebalancing, right? That is, you can find out if the stock price is $90, then hedge ratio is minus 0.453. However, you can imagine if stock price changes to $91, the delta will not be 0.453. The delta you get at the price of 91 will definitely change, which means the original hedging portfolio based on this delta, right, will not be a perfect hedging portfolio if stock price deviates from $90, right? So we could quantify, we could define this kind of change using gamma. What is gamma? Gamma is the sensitivity of the delta to share price. And we know that gamma is always positive if you're taking a long position in options. I'm just trying to define gamma here. Obviously, I will not derive the formula for gamma, and I won't I won't tell you why gamma is always positive. However, you can learn about this if you take a more advanced class. So the economics department actually offers a more advanced class which specifically is about options futures. So if you have interest, then you could take that class. Okay, now let's continue to look at another example, that is cross option speculation. So again, let's say we're still looking at the same firm. So let's assume the risk-free rate is 4%, and the firm is selling at $90 per share, and we assume the stock's volatility is 30%. And now we're looking at two different call options. The first call option, which is a 45-day expiration call, it has a strike price of 95 and it has an implied volatility of 33%. And for a different 45-day call with a different strike price of $90, its implied volatility is 27%. Now, how can you make money from this observation? First, you can see that there is some mispricing here. Why? The reason is because these two calls, they have the same expiration, but they have the different implied volatility, right? So this basically means the call option with the higher implied volatility is overvalued, and the call option with lower implied volatility is undervalued. So you should build a long-short portfolio. That is, you should take a long position in the undervalued call option, and you should take a short position in the overvalued call option. Now, how do you take a short position in a call option? Well, you should sell call, right? You should write a call option. So basically, we know that the basic strategy here is you should buy this call with a strike price of $90 because its implied volatility is lower, and you should write or sell a call with exercise price of 95 because its implied volatility is higher. But obviously you can see that even if you understand the direction of your trade, you still have to figure out how many calls do you want to buy and how many calls do you want to write, right? So here, what do you actually want to do is, again, you want to build a hedging portfolio, because again, just like the last example, what you're really trying to do here, you're betting on volatility. You're betting that the 27% volatility will increase to, let's say, 30%. And you're betting that this 33% volatility will decrease to 30%. So you're betting a convergence of implied volatilities. You're not trying to bet anything on the stock price movement. So if you're trying to build this long short position in call options, you will want to hedge away stock price movement. So how do you do this? Well, you will start again with delta. Here, because you have two call options, what you truly want is this hedge ratio. Remember what is the hedge ratio we discussed in previous example. When we have a portfolio of call option and shares, we define hedge ratio as the change in call option value divided by the change in stock price. It's similar when you're having a portfolio of put options and shares. In that case, the hedge ratio is defined as the change in put options value divided by the change in stock price. Here we don't have stock. Our portfolio have only two kinds of calls. However, the essence of hedge ratio is the same. You want to compare the value changes of these two options. So here hedge ratio is defined as the change in the value of the $90 strike price call divided by the change in value of the 95 exercise price call. And if you define this, you can see that this hedge ratio can be defined as delta of this $90 strike price call divided by the delta of the 95 strike price call. Okay, so after getting this, you could understand basically you will use Black-Scholes formula to find out delta, and then you will use the ratio of delta as the hedge ratio, right? So let's look at the first option, the option with a strike price of 90. Remember, this is the option with lower implied volatility, right? Lower implied volatility. So you will take a long position in this option. And then we could find out D1 here. Again, we have, you can find out all these numbers. So as exercise, try it yourself. So you can find out the delta for the first option is 0.5396. And then delta for the second option, that is the option with a 95 exercise price, its delta is 0.3395. Now, hedge ratio is defined by the first option's delta divided by the second option's delta. So it's 1.589. So what does this mean, right? What does this mean? It basically means if the second option's price increases by 1, then the first option's price will increase by 1.589, right? So this basically means that the first option, this guy, its price is more responsive to stock price movement. So in this case, you can see that this hedge ratio will tell you how many calls you want to buy and how many calls you want to sell. So for 1,000 call options you purchase, you will want to write 1,589 calls. again, you can verify that you're hedged against stock movement because if the second cause, right? If the second cause price increases by 1, then we know that the first cause price will increase by 1.589. And you can see that because we have 1,589 calls. So in this case, for the second call, right, the total increase in value would be 1,589. And then because we have 1,000 first call option, so if per call increase is 1.589, then the total value increase would be 1,589. And then you can see that you're taking a long position in the first call, and you're taking a short position in the second call. So these two numbers will offset with each other, right? So you can see that you're hedged against with the stock price movement. Now we can verify this. So let's look at these numbers. So let's say you will purchase 1,000 calls with the exercise price of 90, and you will sell 1,589 calls with the strike price of 95. And you can use Black-Scholes to find out the call prices. And this will give you the two cash flows. Right? So when you're making a purchase, you will have cash outflow. And if you're selling call options, you will have cash inflow. Right? So in the end, you will get this $151.3 net cash flow. So you will earn this profit. And you want to verify that you're indeed hedged. So now let's say in the end, the implied volatility of these two call options will converge to 30%. So in this case, obviously, again, using Black-Scholes, you can find out these two calls prices under different stock price. So for example, for $89 of the stock, you can find out the 90 strike call would be worth this, and 95 strike call would be worth this. And you could do the same, obviously, for the two other share prices. Right? You could find out all these prices. Now, this is just the per call price. So what is your portfolio's value? Well, you can see that you have 1,000 calls of this guy. So the portfolio value, so your position value, your long positions value would be just 3.578 times 1,000. So you will get this number. And you have reading 1,589 calls. And for each call, its price is $1.703. So if you have written 1,589 calls, then this negative cash flow would be 2,705. Obviously, again, you could do the same for other stock prices. And in the end, you can see that you will get a almost constant payoff, right? Constant payoff. So this basically tells you that no matter what happened, no matter how the stock price would move, that in the end you will roughly get the same sort of profit. Okay, so in this Black-Scholes section, we discussed, I guess, 4 or 5 examples of hedging. You can see that the essence of the hedging is about finding out delta, right? So essentially, this hedging technique is called delta neutral. So why this is called delta neutral? Well, because if you want to hedge against the stock price movement, you're essentially trying to say the delta of your portfolio is zero, right? Remember that delta measures how your portfolio's value will change if share price changes. So if you have a delta neutral portfolio and its delta is zero, this implies stock price changes, your portfolio's value will not change, right? So essentially, delta neutral means zero delta, right? And you can verify that this is the case. For example, purchasing 1,000 calls with a exercise of 90 and write 1589 calls with a strike price of 95 is a delta neutral portfolio, because you can see that no matter how stock price changes, right? No matter how stock price changes, your portfolio's value would roughly stay the same. So the portfolio's delta is just like zero. Okay. Now let's talk about the last valuation approach. Recall that we have discussed two approaches to value options. The first one is binomial. The second one is Black-Scholes. Now the third one is the risk neutral approach. So what's the motivation of this risk neutral method? Well, if you recall the binomial model and Black-Scholes model, when we were trying to price put option price, call option price, we never discussed risk preference, right? So we never discussed how investors are risk averse or how risk averse these investors are. So this basically means that investors' risk preference will not affect the options valuation. So this is actually a very useful insight. It will give us a shortcut to value options. So what is this shortcut? So let's imagine there is a fictional world. It's a risk neutral world. That is, in this world, every investor is risk neutral. So what does this mean? It basically means that investors, they will not ask for compensation if an investment contains risk. So there is no risk premium. The implication is, in this risk neutral fictional world, all cash flows can be discounted using risk-free rate. So you can see that this is a really nice shortcut, because in the real world, when we are valuing cash flows, when we are trying to calculate the present value of a set of cash flows, it's very important for us to figure out what is the risk of those cash flows, because we have to find out the cost of capital by considering risk. We have to do this because in the real world, investors are risk averse. So if your investment project has higher risk, then the cost of capital will generally be higher, right? It's a compensation for risk. And in this risk neutral world, nobody cares about risk. Now everything becomes simple. Just use this universal risk-free rate as the discount factor. This is very convenient, right? And you wanted to know why this could work. Well, the reason is this fictional risk neutral world should value options the same as our real world, because risk aversion does not affect the valuation formula, right? That is, even in the real world, risk aversion will affect cost of capital, will affect returns demanded by investors. But through our learning, we find out binomial model and the Black-Scholes models, they don't depend on risk aversion. So this implies that options value or the value of option should not depend on this risk aversion. Okay, this looks quite dry, and I can understand this actually looks sort of confusing. But let's look at this example. You will see that the logic here is actually quite simple, and you only need very simple procedures to find out the value of your option. So let's assume a risk neutral world, and the risk-free rate is 10%. Again, we have this same sort of setup. So today's stock price is 100. Tomorrow it's either 110. It's either 120 or 90. And we are looking at a call with exercise price of I think it's 110. So you can see that if stock price turns out to be 120, then the call options payoff would be $10. If the stock price turns out to be 90, then the call options price would be just 0. So our question is, what is the call options price? We have solved this, right? We have solved this using the binomial model, and we discussed two different approaches: replication approach and hedging approach. So now we talk about the third approach, that is the risk neutral approach. So let me first show you how this works, and then I will explain what's the essence of this risk neutral method. So let's assume something like this. I'm just using a very vague word, something. So let's do this. So you can see that what I'm doing here is I am trying to discount the stock's future payoffs, 120 and 90. And I try to discount these future payoffs, and I make and I discount these payoffs at the risk-free rate. And the discounted value should be 100. So why this would hold? Well, because we're in this fictional risk-neutral world. And what is the P? Well, the P is the probability the share price will be 120. And 1 minus P, of course, is the probability that the share price would be 90. So this P is the probability in the risk-neutral world. So the P here is called risk-neutral probability. So this P is risk-neutral probability. Now this solves P equals 2/3. Now, importantly, we will carry this P to this call option, because we know that in this risk-neutral world, with probability 2/3, share price would be 1 to 0. Then this implies in this risk-neutral world with probability 2/3, the call price would be 10. And with probability 1/3, the share price would be 90, and the call value would be 0. Sorry, the payoff of the call would be 0. So again, we would discount this using the risk-free rate. So this gives us 6.06. This is the exact number we got from using binomial models. And you can see that this is really simple, right? The math here is really like kindergarten math. And what are the, maybe let me summarize. How do you find out your result here? So you can actually consider this as a two-step process. Right? What is the first step? Step one, you will find risk neutral probability. So how do you find out this risk neutral probability? Well, you will use stock price. You will use the share price because you know that the share price could be either 1 to 0 or 90. And you know that if you discount this expected cash flow from this share at or using the risk-free rate, then you should get its present value, which is 100. So this will solve P. The second step is you will use the risk neutral probabilities, right? You will use the risk neutral probability to price your call option. Now, how do you price this? Well, you have this, you've already got this risk neutral probability. So you would know that with this probability, what is the cost payoff? With this probability, what is this cost payoff? So you would again, right, discount this expected payoff with the risk-free rate. So this gives you the correct call option price. So this seems like magic, right? Why it actually works? Well, the explanation is actually quite interesting. Think about what is the risk neutral probability. It is not the correct probability that the stock price will increase in the real world, right? So it is not the true probability of the stock price increasing in the real world. It is the it actually represents how you should change your probability to keep the stock price the same in a risk neutral world, right? So it's just a fictional probability in your risk neutral world. Now think about the risk-free rate. It's not the true correct discount rate in the real world, right? It's just the correct discount rate in this risk neutral world, right? So you can see that in some sense, risk neutral probability and the risk-free rate, they're not the correct number to use in the real world. But the interesting result is these two errors, these two incorrect usage will just cancel out with each other and we will obtain the correct result. That is, if you look at this, result, what you can see here is 10% is not the correct rate you should use to discount a call options payoff in a real world. And this 2/3 and 1/3 probability, they're not the correct probabilities you should use in the real world to calculate the expected payoff from your call option. However, you can see that they are the correct number to use in a risk neutral world. So if the valuation does not depend on risk preference, then the value you get in the risk neutral world should be the same as the value you can get in a real world where risk actually matters, right? And you could also see that or you could see this from the perspective of the real world. In the real world, you put incorrect number in the numerator, and in the real world, you put the incorrect discount rate in the denominator. And then you can see that these two errors will just cancel out. So you will get this correct result. Okay. We have a general formula here. Oh, I didn't know I have this page here. So let's say if we assume today's share price is S and tomorrow's stock price would be SU, that is the up price, and SD, that is the down price, and correspondingly option price would be CU and CD. So let's now apply this two-step process, right? So we would first compute the risk neutral probability. Now, how do you compute this? Well, you will want to make the stock's expected return equal to the risk-free rate. Okay, this is not a very good presentation. So if follow our lecture note, this is how you calculate risk neutral probability, right? That is, you discount the expected payoff of the stock with the risk-free rate, you get the stock's current price. But obviously you can see that this approach and this approach, they're the same, right? So they're the same. So you can see that this could help us to solve the risk neutral probability, which is 1 plus the risk-free rate times the share price times the down price divided by the up price minus down price. And next, obviously, we could value I think this is a call, right? So we could value the call. Call option would be the risk neutral probability times CU, that is the call's payoff if stock price increases, plus 1 minus P divided by CD and discounted by the risk-free rate, right? Okay, now let's look at this example. Oh, sorry. So using Narvar network systems from the example, so we imagine all investors are risk neutral. So basically, obviously, we are thinking about a risk neutral world, right? So calculate the probability of every state in the next 2 years. And you can see that the picture on the left gives you stock prices. And we know that if you give me share prices, I can find out risk neutral probabilities, right? And use these probabilities to calculate the price of a 2-year call option with the strike price of 60 and price a 2-year European put option with the same strike price. So let me show you how do you find out the risk neutral probability. So let's say we first find out this P here. How do you find out this? Let me just use the formula here. So let me just use the formula. So P equals 1 plus RF times today's share price 50 minus SD, so minus 45, and then 50 minus 45. Oh, we still have to plug in RF here. So the risk-free rate is assumed to be 3%. So this gives us 0.433, right? 0.433. Now, can you find this? Again, you could use the same method, right? So the P now would be 1 plus 3% times stock price, 60, minus the down price, 54. 60 minus 54. And you can find out the stock price here is the same, right? So this would be 567. 567. And then 567. 33. Okay. So now we have find out all these risk neutral probabilities. So now we could price this 2-year call option with a strike price of 60. So now let's see how could we find out this. Remember that this is a risk neutral world. So what you need to do is you just try to discount the options payoffs using the risk-free rate. But how do you find out the options expected payoff? Well, we have found out these risk neutral probabilities, right? So let's look at this call. We know this call has a strike price of 60. And let's look at these different stock prices. Okay, let me use a different color. Right, this and this. What you can see here is if stock price is 72, your call's payoff is what? Is 12, right? So your call's payoff is 12 if stock price is 72. And if stock price is 54 and 40.5, the payoff from your call would be just 0, right? Now, what is the probability that the stock price would turn out to be 72? Well, you can see that it has to happen first like this, and then the path would be like this. So this means the probability is 0.433 squared, right? And the total probability of these two cases would be 1 minus 0.433 squared. So now we can calculate the call price. So the call price would be, with this probability, we will get $12. And with this probability, we get nothing, divided by the risk-free rate. So this gives us, so what we can get here? Oh, sorry, I forget the, well, because we have we have a 2-year call option. So I have to put a squared here. So this gives us 2.12, right? Okay, now let's look at the put option. The idea is quite similar to value the call option, right? So we have a put. Its exercise price is 60. And let's look at the put payoff here. So if stock price is 72, then the put payoff is just, it's just 0 because it's a put, right? So it will expire out of the money. And if stock price is 54, then the let me see. the profit would be 6. If it's 40.5, the payoff would be 19.5. Now, what are the probabilities? Well, we have learned the probability that the stock price turned out to be 72 is 0.433 squared. And the probability that the stock price turns out to be $54 would be 0.433 times 0.567, right? You can see that you have two paths. The first path 50 to 60 and 60 to 54, and the second path 50 to 45, then 45 to 54, right? So that's why you have to times 2 here. Now the probability to get to 40.5, you have only one path, right? You would just go first from 50 to 45 and 45 to 40.5. So in this case, you would get 0.567 squared. And now after getting these risk neutral probabilities, it would be very easy to find out the price of the put, right? So it should be 6 times the probability plus 19.5 times the probability, and then discounted by the not 10%, then discounted by the 3% annual rate. So this gives us a value of 8.68. So you can see that risk neutral, if you compare risk neutral probability approach with the binomial approach, you can see that risk neutral approach is actually, at least in my opinion, I think it's actually simpler, right? And you can also see that Black-Scholes model should be a very important model because it gives you this very nice formula which directly tells you the option value. It directly gives you the delta, and then it actually makes creating a hedging portfolio very easy, right? You just plug in numbers, then finding out hedge ratio, then you could build your portfolio according to this hedge ratio. All these valuation approaches are all quite important, and I would say the requirement here is I want you guys to understand this hedging approach. You can see that we really discussed a lot on this hedging ratio, hedging portfolio. The reason is basically for options, there are two main functions. The first is you could use options to make some sort of speculation. Then the second application is risk management. When you're talking about risk management, then you're essentially trying to hedge against risk. And I would say understanding these three valuation approaches is also very important if you want to take further courses in to understand options, futures, and other more complicated derivatives. Okay, that's for today's class.